Part 1 covers 4 main points. Number 1, making enemies to work with the soft lock, including having the option to toggle off the targetability of the lock. Number 2, a widget blueprint to place over the soft locked actors. Number 3, a blueprint interface to handle passing logic between the player and other actors in the level. And number 4, showing the soft lock widget on the nearest actor. Starting off real quick, we're going to open up the content drawer and we're going to copy the third person character and rename it BP enemy. These are going to be one of the actors that we have the soft lock targeting, so we can drag 2 of them into the map. And we just need to open up the blueprint and change the collision settings. We can change it from pawn to custom. The reason why is we want to have the visibility set to block, otherwise if we do any traces, we're not going to scan the enemies. After that, we'll open up the third person character. So we're going to have to set up a couple events. The purpose of this is that we're going to get a multi-sphere trace by channel. And we're going to center it on our player's location, so we can get actor location. It's going to be the start and the end, and the radius is going to be 2000. This event is going to be our soft lock start, so we can create a custom event and call it soft lock start. And we'll get to activating this in a second. We're going to have to declare a couple of variables before we can put this into a loop, so then it keeps looping through our soft targets in case we get out of range, or in case any actor is no longer to be included in the pool of characters that can be soft locked onto. We're going to get a for each loop. And we're also going to get a break. So from where we're standing, every enemy within a radius of 2000 units is going to be hit by the multi-sphere trace, and then it's going to be collected in these out hits. If it hits at least one of them, we'll go through each element of the array. We're going to break the array element. And then we reach our first design decision. There may be enemies that we do not want to have targeted. So it would be nice to have the ability to remove targeting as an option. And we also want to make sure that if we hit something, it's not a random piece of geometry. So we need to differentiate between the enemies that we have and any objects that we might want. So we're going to make use of a blueprint interface so that anything that uses this interface is going to be targetable. And then we're going to have a function in that interface to toggle on and off whether or not something could be targeted. So we'll open up the content drawer again, right click, and we can type in interface. And get the blueprint interface, and we're going to name it BPI_target lock. The first function that we're going to use is going to be can be target. And it's going to have one return value, a boolean, can be target. In our enemy, we're going to go to our class settings, and right under interfaces and implemented interfaces, add what we just made. Then we can double click on can be target from the interfaces section, and we're going to want to check that to be true. And back in our third person character, drag out the hit actor. We can say does object implement interface. In the drop down, we're going to have BPI target lock. And we also want to make sure that we can send a message to our actor. So we can call the function that we just made in the interface. can be target message. And we'll get an AND bool. If both of these are true, we're going to add this hit actor to an array of actors. In our variables, click plus, and we'll say targeted actors. Of type actor. And get the object reference. And then, up in the variable type, click on the blue node, and we'll change it to array. And we can drag this in, and we're going to add unique. This way, since we're going to be eventually looping this to make sure that this is updated and current as often as conceivably possible, we don't want to keep adding the same actor over and over again. That's why we use unique. So say we run through this twice. Something changes with this can be target, and this hit actor is already in our targeted actors. Off of false, we're going to remove the actor. Get remove item. And it'll compile and we'll save. Now to run through this, I'm going to get a keyboard. I'm going to bind it to E. And I'm going to make a new custom event. The event's name is going to be area scan. And when we press E, we're going to run this event. When we run the area scan, we're going to initially call our softlock start. Then we're going to set a timer by event. We'll drag off the event, get a new custom event, and we're going to call it soft lock loop. We'll change the timer to looping. We'll promote the return value for our timer handle to a variable. We'll rename it soft lock loop timer. And then we want to set our time to half a second. We'll drag in our target actors, and we're going to get a for each loop. This is going to be incorporated with the widget that we use in just a moment. But after we loop through, we're going to call our soft lock start again, and just have this be on completed. To run through what we've done so far, we press E to start our area scan. Area scan initially does our soft lock start, and every half second afterwards, we still go through the start. We do a big area scan of 2000 units, getting every actor that both incorporates the interface and is able to be targeted. And then we add every viable actor to this list of actors. Actually, as we run through this loop, we're going to clear on completed, and then we're going to run it again. That way we can remove any old actors that may not be in the level anymore. Or if there's anything that changes their status before the next update, we want to make sure that we have the most updated information for our array. Now that that's updated, we're going to go back to the completed of our soft lock start. We're going to use this completed to call another timer that is going to continuously update which one of these targets is the closest to us. After we do that, we'll move on to making a widget, so then the closest target will have the widget displayed over them. So we'll get a branch and drag it into the completed. We'll set a timer by event. And just so I don't have bridging connections to multiple events, we're going to create a custom event separate from the timer. This one is going to be called Get Closest Target. We'll drag off the event, and then we can create event and select what we just made from the dropdown. Want to promote this return value to a variable as well, and we'll just call it line of sight timer. I'm going to abbreviate it as LOS timer. And we want to make sure that this is not continuously firing off, so we're going to drag in the handle. We're going to say is timer active by handle. We'll drag it in and then just move this to the false pin rather than getting a not bool. And the time that we update this, we can just say 0.05 seconds and make sure that it's looping as well. Get nearest target. Going to take one input. It's going to be our target actors. And it is going to be our actor array. So type actor and change it to array. Then we can drag in and get a for each loop. And then we're going to get a line trace by channel. Our starting location is going to be our player character, so we can get actor location. And the endpoint is going to be the targeted actor. So we'll also get the actor location of the array element. For debugging, I'm going to change the draw time to 1 second. And change the type to duration. Then we're going to add two outputs. The first is going to be of a type actor, just the single, and this is going to be our nearest actor. And the next variable we're going to make is going to be of a float called nearest distance. After our line trace, we're going to get a branch, and we're going to break the out hit. We're going to drag in the array element, and then we're going to type in equals equals. We want to make sure that if we hit something, it is going to be our hit actor. So if it is intercepted at any point, we're not going to count it as the nearest actor for our soft lock, even if it may be the case that it's the closest, because we don't want to soft lock onto something that is on the other side of a wall. And we want to make sure it hits, so we'll get an AND bool off of our return value for the trace. Connect both ANDs. If we did have an actor that was in the array, however, it now is blocked in line of sight, we can remove it from consideration from our soft lock by calling our targeted actors and then removing the actor. So off of our false, we remove, and if it is true, get another branch, and we want to get our distance to. Our target is going to be self, and the other actor is going to be the current array element that we're checking against. We'll promote our return value to a local variable. We'll call this distance to target. And for our branch condition, we're going to check to see if either our get distance to is less than what we currently have for our distance to target, or if our distance to target is equal to 0. That way we either update, or if it's the first time we're scanning a target, we set the distance. And assuming that these are true, we'll drag in our array element, and we'll promote this to a local variable as well. And checking what I named the nearest actor, we'll say nearest target. Then we can compile. On our return node, we'll connect the completed pin in our nearest target, the nearest actor, and distance to target is the nearest distance. And we'll go back to our event graph and we will drag in the get nearest target and connect in our targeted actors. We will likely need to call these variables later on. I'm just going to promote both of these to a variable now. Our nearest actor is instead going to be our selected target. We're going to change one thing. Get nearest target, distance to target. We'll just rechange. We'll just rename this to distance, just because it's a local variable. And off of the event here, this will be distance to target. And just in case we lose the target, we want to get an isValid node here. Here's the one with the question mark. And we're going to check to see if our nearest actor is valid. Now with everything done right, we should be able to highlight our selected target and constantly update which one of our targets is the closest to us. So now we want to make a widget to display on that target. We'll open up the content drawer again. We'll just type in widget and get widget blueprint, user widget, and rename it WB_target. I'll leave the design for this mostly up to you. I'm just going to get a canvas and a text block and drag it in. I'm going to anchor this to the center of the screen, zero out the position of X and Y, and the text is just going to be an exclamation point. We'll align the text to center. And this is going to be our soft lock icon. And then we just want to make sure that this is checked as a variable. Back in our enemy blueprint, we're going to add a widget. And we're just going to rename it target widget. And for our space, we're going to change it from world to screen. This will allow the widget to always be appearing on the screen. So if there's an object between the player and the soft lock target, they'll still be able to see the soft lock and geometry won't block it. Then for the widget class, from the drop down, you get WB target. We're going to be sending events from our scan to toggle the visibility of our soft lock onto each of our enemies. So in our target lock blueprint, we're going to create a new function for the interface, and it's going to be called soft lock widget. For our inputs, we're only going to have one, and it's going to be visibility. And the type is going to be eSlate visibility. Compile it, and we'll go back to our enemy. Just double click on soft lock widget. Drag in our target widget. Drag off the target widget and get user widget object. And from the return value, we will get soft lock widget message. And we will connect the visibility. Then in our widget, go to our graph. We want to click on class settings, and we're going to implement the interface here as well. So BPI underscore target lock. Compile, and soft lock widget. Double click. We get the soft lock icon, and we get set visibility. Now we go back to our third person character. And all the way at the top of our soft lock loop, we only want to have that lock active on one actor. And since this updates every half a second, we just want to take the soft lock widget and set it to be hidden. So we could drag off the array element, call soft lock widget as a message, and set it to be hidden. To designate what should be the correct actor, we can go all the way at the end of our get closest target and set the soft lock target here onto our selected target and set the visibility to be visible. And now back in our widget blueprint, off of pre-event construct, we're going to get the soft lock icon, and we're going to set the visibility to hidden. So we start off with this icon being invisible. All right, so if we test this out, we press E, we can see that there is a tiny exclamation point closest to this. Then when we get closer to the other enemy, it swaps. Probably change the font size just to make this a bit more noticeable, or you can add in your own decal. say 64 size font. Yep. And now you can see that the icon is rendered to the screen, so then we can see it through our own player character and see it through objects. And there was a single flash of both actors having the icon on them at the same time. A quick fix for that is for our soft lock widget. We could copy it and we'll go into the get nearest target. And as we loop through everything, we can just toggle it off by default. So if we try it out again, we see that the icon is only sticking to one of them at a time and correctly disappears onto the other if the first one is blocked by line of sight. Though interrupting line of sight switches the target, it doesn't do so in a way that we want. So I'll be going through this in part 2, as well as ignoring the actors that are off the screen and disabling the lock if no applicable actors are within range. So make sure to subscribe for part 2 or for more in-depth tutorials in the future. Thank you to Winterberry Shark and Thatcher Moss for their support on the Patreon, and you can also join the Patreon and the Discord for updates, tutorial suggestions, and more. Links are in the description. So thank you all for watching, and I'll see you in part 2.